Hello everyone, and welcome to part 2 of these Choropleth maps lecture series. In part 2 we're going to focus on international or world scale maps. Part 1, which is the last lecture, we focused on USA and nationwide Choropleth maps. Now we're going to go ahead and change this up to a world international level. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, here I am at the Jupyter Notebook. Last time we left off on U.S. agricultural exports by state. Let's go ahead and move on to our next data set, which is a world GDP data set. I'm going to go ahead and comment out that last plot and say df is equal to pd read CSV, and we're going to go ahead and open the 2014 world GDP data set and then check out the head of that data. And we have a country name, GDP in billions, and then a country code. So this is just a standardized code for international countries, basically the same as the state codes that we saw earlier. We're going to go ahead and use this as our Z value, this GDP, country as maybe a text, and then the code as the actual code to pass in for the Choropleth mapping. Let's go ahead and start creating our data variable. Again, we call a dictionary. We say type is equal to Choropleth, just like we did last time. We go ahead and say locations, and locations is going to be equal to the code column. Then for the Z value, we'll go ahead and set that equal to the GDP in billions. We'll go ahead and set text equal to the country column in the data frame. And then we'll go ahead and set color bar argument. And here we have that dictionary where we pass in the title as a key and then a string value for the title. And we'll just say GDP in billions US dollars. And that is our data object. And now for our layout variable, we'll go ahead and say casting as a dictionary. We will set the title to be equal to the string 2014 global GDP. And the next thing we're going to do is set geo is equal to, and then it's going to be another dictionary. And let's go ahead and say show frame. I can actually put this on the same line. Whoops. Show frame is equal false for now. And the next argument we're going to say is the projection. And you can reference the documentation, but for now we'll just set the documentation projection default, which is this Mercator projection plot. It looks like we have our dictionary ready to go. Let's go ahead and say Choro map 3 is equal to go.figure data equals data passed in as a single item list, and then layout equals layout. And then we can just call iplot on Choro map 3. And here we have our 2014 global GDP. And you can see that the scale here basically just points out the main outliers, which is United States, China, and then some of the more developed countries or larger population countries in the world. Now, as I've mentioned quite a few times, in order to do this sort of plotting on your own, you're probably going to have to reference the documentation or the Jupyter notebooks. And I kind of wanted to explore that reference with you. You can go ahead and click on the link provided in the Jupyter notebook, or just go to plot.ly/python/reference. And here is basically a full reference to all the arguments you can pass in to all of Plotly's plot types. And you can scroll down here to the map section and click on Choropleth to get to the Choropleth section, and you can see the various arguments you can pass in here. And you can check something like, for instance, the projection. If we continue down here, or you can actually just search for it. So I can search for a projection I know is in here, and we can have type. And here we're under Choropleth, and we can go ahead and pass in maybe another projection type. That means we can just grab one of these strings. Let's go ahead and just grab this one. That's another projection type. I just come in here, replace this string with it, and then run this plot again, and now I have a different projection type. Notice here how the countries are shaped a little differently. You can go ahead and continue exploring these, such as a stereographic projection. Come here, copy and paste, and rerun. And that's basically what you do when you're kind of playing around and exploring these libraries. So here's another projection. You can actually kind of spin this around. It's a little weird. It's kind of an inverted globe feeling. But you can go ahead and play around with these and explore them on your own. One projection that's nice to look at is the natural Earth projection, which if you just go ahead and pass it in here, natural Earth, and then run this again, you get basically a nice natural looking Earth. And you can pass it and pull it, and you can see the rotation here on the planet. Okay, go ahead and explore the documentation. That's a big part of learning how to use these sort of Choropleth and more complicated geographical plotting libraries and capabilities of Plotly. Like I mentioned before, quite a bit of this has to do with what your data looks like. If your data is not in a format that Plotly can accept, you'll probably have to go to use another geographical plotting library. But hopefully you're able to convert either a country code or country name into an acceptable format for Plotly. Alright, that's it for this lecture. I hope you enjoyed it and seen the power of Plotly. Even though it's a little hard syntax-wise, for just a few lines of code, really, I mean, this is just about 15 lines of code, maybe even less, you're actually able to make a very nice looking interactive visualization on a geographical international scale. All right, thanks everyone, and I'll see you at the next lecture.